Okay, so we're back talking about our previous book, book number one, A Fortunate Universe, and we've been talking about some of the reactions that we get from even trained cosmologists about this question of fine-tuning in the universe, right? And it can be a controversial topic. So one of the responses that we get, and when you hear this response, you have to hear it in your best Jeff Goldblum voice. Is that essentially, evolution will find a way that life is somehow resilient, right? So life will thrive in environments very different to the environments we're used to, and we already know on Earth that you can have life in the frozen wilderness of the Antarctic, and you can also have life in the scalding waters of hydrothermal vents and all this kind of things. And if we can get life in these extreme places here on Earth, then surely we should expect life at extreme places in the multiverse.
Right. The scrap of truth in this objection, which I think you've got to point out is, the thing that fine-tuning does is we look at other ways the universe could have been, and we try to ask the question, could life happen there? And you don't want to just say, if I dropped a human being there, would they be comfy? Right, you want to be a bit more general than that. And so, as part of that, you've got to have some sort of understanding about the limits that life can take. And so it is true, we need to take these sorts of things into account, and it is surprising the sort of conditions that some sort of microbe has called its home all over the Earth. The problem is, if you're a biologist, then the Antarctic and boiling hot water, those are sort of the extremes of hot and cold. If you're an astrophysicist, that's like a really nice narrow range for us, right? Yeah. That's not like so. The Antarctic, what minus 50 degrees Celsius. I think the hottest that a microbe has been found, it's actually, thanks to the pressure, it can get higher than normal boiling point. So it's like 120 degrees. Okay. On a scale of Kelvin, which is our favorite, which starts at absolute zero, but each step is then the same size as a step in Celsius. That's from, minus 50 is about 220, and then plus 120, I'm now having to do this, what's that, about 400?
Roughly 400.
Okay. So let's say 200 to 400, okay? And then we go out and look in the universe, and we see molecular clouds where the temperature is like 10 degrees or even less, right? And the sort of temperature of empty space in the universe, it's not really empty space, there's light there. The temperature of that is 3, okay? And then we see clouds of gas that are lit up as stars, and they're at 5,000. And we see like the corona of the sun, which is at like 1 million. So actually these extremes of 200 to 400, when you look on an astronomical scale, aren't really extremes. And so when we go out looking in the multiverse, we're not really looking for temperature extremes. What we're looking for is any sort of structure.
Yes.
So will there be stuff stuck to other stuff, and will that stuff stick together in a way that it won't fall apart? So the sort of criteria you rely on are very general things. Like, so suppose when we say, if the cosmological constant's too large, then you won't get life. What we don't mean is it would be too cold for any sort of life that we've thought of so far. What we mean is literally there will be no 2 protons stuck together in the entire universe. Right? Every single particle will be surrounded by a couple of trillion light years of empty space. Or if you change the fundamental masses of the particles, what's going to happen is the basic stuff of the universe is going to fail to stick. And so you won't be able to build up any complexity because it'll all just fall apart. So as long as we take that little lesson into account and we keep that in mind, and we don't have a too narrow view of the way life could happen, then evolution won't find a way unless it's got some way to start.
Yeah, well, so I think this is one of the key points that people sometimes forget, is what we're talking about. There's several different aspects here, right? So evolution is something that happens once life is started.
Yeah.
Right? And this question of extremophiles on the Earth,
yeah.
the creatures at the hydrothermal vents and the creatures in deep Antarctica, they all share the same common ancestry as all other life on Earth. So the question is, where did life begin? Where is the most the most likely place that life began. And if you talk to scientists who work in this, it's in these warm, salty pools on the edge of a sea kind of thing, right?
Yeah.
It's not that hydrothermal vents were a good place for life to start, but it was a good place for life to find a way to survive once life had begun.
Yeah.
Right? So the real question at some level is, how did life begin? What are the conditions like for life to begin? And we really don't, and we don't know, but I recently gave some talks on this, is that the conditions that it looks like on Earth, you needed water, but you also needed shoreline, so you needed a mix of land and water, and all these other things that come together that suggest that even life in our universe itself would be rare, because the conditions for starting life would be rare, that you have water and shores and tides and all this kind of stuff. So, but that's a separate question again about it's not just the sites and conditions for life in terms of what we have in our universe, but the general conditions for there to even be a planet in the first place, or a star in the first place. So this notion that life will find a way doesn't really answer anything. What it tells you is that life will find a way, maybe if you've got somewhere where life can start, and then niches that life can fit itself into, because it looks like we do have life just about everywhere over the surface of the planet. But that started somewhere and spread. That way evolution did find a way. But that doesn't answer this question of life in other universes. Right? Evolution doesn't solve any of that.
Right. An important thing, I think, to remember is that range of, say, 200 to 400. When we think about that, the reason we're not looking too far outside that is not because we haven't found anything out there. It's because we think about the basic things that a life form would need to do, and it would need to sort of like store information somehow, and it would need to undergo some sort of chemical reactions to do something, do anything. And outside of that range, bonds start to break on a most basic level. It's not that we're assuming much about life. We know how strong chemical bonds are.
Yes.
And outside a certain range, they all break. And lower than a certain range, chemical reactions just don't happen. You just, everything will be frozen solid. So you said the pools we need. One of the reasons we need that is so we can get some chemicals sequestered off, and then they need to be in a liquid form. Well, it'd be best if they were in liquid form, so then they could sort of mix around and try some stuff and maybe do something interesting like life.
Yeah.
So these are very general considerations, and what life, as you said, what life can adapt to doesn't answer the question of why this universe, threw up life in the first place, threw out some life for us in the first place.
Yeah, Jeff Goldblum doesn't help.